when what is called the saturated vapor pressure equals the atmospheric pressure. When the liquid is heated, the molecules gain greater kinetic energy, hence move faster. So molecules at the bottom and in the bulk of the liquid will be moving to the surface of the liquid as a result of gain in kinetic energy. Kinetic energy is energy for motion. So because the molecules of the liquid have greater kinetic energy, they move to the surface. And some will now acquire so much energy that they escape out of the bulk of the liquid into the vapor phase. So you now have the molecules in the liquid phase and also have the molecules in the vapor phase hovering over the liquid. That happens, and you will agree with me that molecules, the escape of molecules, the movement of molecules from the liquid state to the vapor phase is evaporation. Is what? Evaporation or vaporization. It is not only going to take place in one direction. Molecules in the vapor phase will also return to the liquid phase, and that is called condensation. That is called what? Condensation. Those two processes will be taking place until their rates become equal. Equilibrium is attained. When the rates of two opposite processes take place or become equal, that is equilibrium, dynamic equilibrium. Do we agree? You were taught that just a week ago. So when you now have molecules escaping, that's to say we have H2O liquid change to H2O in the gaseous state, and then the reverse takes place, and a time is attained or is reached when the rate of the forward reaction is equal to the rate of the backward reaction. Equilibrium attained, and we measure the pressure of the vapor over the liquid. That pressure is called the saturated vapor pressure, simply written as SVP. And it is a characteristic physical property of a liquid at a given temperature. That's why every liquid at a defined temperature has its particular value of saturated vapor pressure. Even when you see liquid, that is ponds, that is water bodies, even on the road in gutters. Scientifically, the reality is that some of the molecules are not in the liquid you see. Some are hovering in the vapor phase over the liquid. They return, condense, especially when the temperature is high. For example, when the sunshine increases, evaporation supersedes. But there always comes a time when the rate of evaporation is equal to the rate of condensation. And because we are talking about the vapor phase over the liquid, that is the gaseous state. So it has pressure. One of the key parameters used to define a gas is the pressure. So the vapor phase of the liquid has pressure. When that pressure is determined at equilibrium between evaporation and condensation, it is called the saturated vapor pressure of a gas. When you heat the liquid, when you heat a liquid, you will expect evaporation to be faster. Why would you expect evaporation to be faster when you heat a liquid? Because heating, remember one of the postulates of the kinetic molecular theory of gases says that the absolute temperature is a measure of what? The average kinetic energy of the molecules. Are you with me now? So you are now heating. The molecules gain greater kinetic energies. So evaporation becomes faster. So as more molecules come to the vapor phase, the pressure increases. But there is a pressure acting downwards on every subject or object on the surface of Earth, and it is called the atmospheric pressure. It is called what? Atmospheric pressure. Depending on where you are, the atmospheric pressure varies. We say atmospheric pressure at sea level is about 760 millimeters of mercury, equaling 1.0 atmosphere. Are my students following me? I don't want to be fast. I want you to understand the concept. So when you now heat a liquid, the saturated vapor pressure builds up as a function of the temperature. It increases, say, from 0.1 atmosphere to 0.2 to 0.3. But remember, the atmospheric pressure is constant at a particular point. So as the saturated vapor pressure keeps building, it will come a time that the saturated vapor pressure equals the atmospheric pressure. When the saturated vapor pressure building up from within equals the atmospheric pressure. There will be free escape of molecules in the gaseous phase. So the molecules in the liquid phase will come to replace it. That is when the liquid is said to have boiled. It's said to have what? Boiled. That is boiling. That is what? Boiling. That is boiling we are talking about. So I want you to understand that we can explain the properties of the liquid, of the gas, of even the solid phase, depending on those postulates of the kinetic molecular theory. But because we are considering strictly for now the gaseous state, there are laws that explain how gases behave.